All right. Good evening, graduate UNSY students. First, as a reminder, we are recording this session. A copy is going to be made available for those who are unable to attend tonight. Next, for the format of our meeting, I'm going to start by introducing our guest, and then we're going to proceed into a brief presentation, followed by a facilitated Q&A discussion. After that, I'm going to open up to a wide, class-wide Q&A. In the meantime, I do ask that you all mute your mics, save any questions you have to the end, that use the hand raise icon to indicate when you do have a question. I'll try to call on each of you in order. You can also populate the text chat with your questions, but please wait until we're at the Q&A stage. Otherwise, it's going to be distracting. With that, I am just really thrilled to welcome you to the 44th session of the UNSY Guest Me Speaker Series. This is the second of 3 for our term together. I'm Dr. Brent Terwilliger, the Program Coordinator for the Master of Science in Uncrewed and Autonomous Systems degree here at Embry-Riddle Worldwide. Tonight, we are joined by our guest subject matter expert, KClutts. Kendall is an avid RC hobbyist, a general aviation pilot, and an aircraft owner. His passion for aviation was nurtured during his childhood experiences with remote-controlled aircraft. This foundational experience, it led him to attend Embry-Riddle Aeronautical University from 2014 to 16 at the Daytona Beach campus. This is where he earned his Bachelor of Science degree in Unmanned Aircraft System Sciences. During his tenure at Embry-Riddle, Kendall participated in numerous experimental platform development test campaigns and counter-unmanned aerial vehicle exercises. Kendall's professional experience, it encompasses the UAS industry. He has collaborated with organizations such as GoPro, GE Aviation, Flex Innovations as a team pilot, and now Boeing. Currently, he holds the position of Flight Test Lead and Developmental Test Pilot for AuroraFlight Sciences Skyron X Expeditionary Small UAS. This highly modular Group 2 sub-55-pound Part 107 compliant electric vertical takeoff and landing UAS, it possesses an impressive endurance capability of up to 7 hours in its fuel cell configuration. With that, let's give a warm welcome to Kendall. I am really excited to explore this field together over the course of our discussion.
Thanks, Brent. That was an awesome intro, and I really appreciate it and excited to be here. I'll have to make a stop by campus sometime soon. Every time I've been in the area, it seems to change every time I see the Daytona campus just from Clyde Morris there. But yeah, I actually keep an aircraft there nearby. I'm a frequent of the creek just south of Daytona, so pretty local, living up in Gainesville, and I split my time between Gainesville and our headquarters site where we do a lot of our flight testing up in Virginia, but we've got a couple different sites all across the country and over in Europe as well. So I'll give a quick intro to who Aurora is and what we do. 35-year-old company, and probably the coolest thing about Aurora is it's 35 years old, and they've developed, their claim to fame right now is they developed 35 aircraft in 35 years. Crazy breakneck pace. Some of those aircraft were napkin drawings all the way up to first flight technology demonstrators. So pretty impressive place, pretty cool place to work. Some of you might notice a familiar cockpit there on the upper left quadrant, and some of the DA-42s down there on the bottom right quadrant. One of the coolest things and one of the largest programs at AuroraFlight Sciences is the Centaur program. Centaur is an optionally piloted aircraft. So what you're seeing in that cockpit view is the right seat comes out and a whole flight computer sits in the right seat, and it's totally optionally piloted. It's right there in the name, Centaur OPA. So that's a pretty cool program, and a lot of flying goes on, and it's an excellent R&D platform that gets used regularly for the company. But we're about 1,000 employees, 5 locations, 4 in the US, 1 in Switzerland, and we became a part of Boeing in 2017. So we've got a couple of pretty big focus areas, and the biggest one of late has been autonomy and robotics. And then some of what I've been working on is electric propulsion and hybrid lift and hybrid propulsion for eVTOL. So where are we? We've got locations in Manassas, Cambridge. We've actually got 2 in Boston and Massachusetts there. We've got a Cambridge lab and then the Boston lab. I spend quite a bit of time flying between my home in Gainesville, Virginia, and Boston's, and then hopping specifically between those two sites. There's just a ton of action going on there. We've got a ton of air structures manufacturing in Columbus, Mississippi, and Bridgeport, West Virginia. And then we've also got our ASA office, Aurora Swiss Aerospace in Lucerne. So that's a couple of our different locations. What we do, I've kind of talked about a little bit of this already, but we focus on research and technology, development, manufacturing, and then you'll get a little bit more of a preview here of the SUAS side and where I've been working in the SUAS product development on the Skyron X program here shortly. So I'm a member of what is called the Engineering and Test Organization. So there's 500 engineers within that organization. There's 8 engineering and test divisions. I'm actually in system tests and operations. And between all of those engineers and engineering divisions, there's 40 programs and projects going on presently. So this is just a couple of the ones that are a little bit more public. And you've probably heard something about. Ton of X-plane development going on within Aurora, which is really cool. So there's a lot of very niche new technology being developed and a lot of cool new ideas being tried out. That's kind of Aurora's sweet spot, is the cool thing, the new thing, the experimental, and taking it to that next level. So another neat little statistic here that as I was preparing for this kind of found out was about 60 or 70% of the organization is engineering or manufacturing. That's pretty impressive. In my career, I've kind of seen 50-50 mix or less of the engineering side and a lot more of the biz ops, business development side. We're focused on the engineering and operations side, which is a fantastic place to be. All right, so now we're going to get into the meat and potatoes of what Skyron X is here. So I don't know if the audio is coming through, but it's not necessarily. Is it? Does it sound all right?
No, sorry, it's not. Just the visual.
That's all right. So I'll just let it play for a moment, and I'll see if I can get it going. Nope, we're just going to let it run. Don't need it. Anyway, this is Skyron X. Skyron X, and I'll get into the specs here in just a second. It's a pretty impressive platform, 16.5-foot wingspan, up to 7 hours of endurance, depending on the configuration. We have 2 configurations. We have a fuel cell, which is still in the developmental flight test phases, and then our battery configuration, which is probably the most standard configuration for the aircraft. That's right around 3.5 hours of endurance. So 16.5-foot wingspan, under 55 pounds, 3.5 hours endurance in all 3 of its configurations on battery with the different payloads we validated and integrated right now. So you're seeing a little bit of that on screen. Our payload partner, Trillium Engineering, we've worked really close with them to make everything hot. Well, I shouldn't say hot swap, swappable with just 2 screws. We do encourage people to power down before they swap payloads, but it's just 2 screws, 1 torque wrench, everything's 12 inch-pounds. That's all you need to know about the platform to put it together. And so beyond that, it's really suited for the intelligence, surveillance, reconnaissance use case right now. There's nothing that says it can't. There's your payload swap. We can't just slap a LiDAR or a photogrammetry payload right onto the front of the aircraft. It's pretty much ready to go for that with the blind mate connector there and that bulkhead. So pretty powerful platform, something that I've been wishing was around for quite some time. You heard me talk about some of the specifics here. Some of this is a little buzzy and salesy, and that's just because this is the approved, typical stuff that goes out. But let's talk about it a little bit. Cruise is right around 36 knots. It's comfortable cruising down as low as 30, 32 knots. Max dash speed is what we call it, is 50 knots. Wingspan, I told you, was 16.5 foot, 16 foot 6 inches. And it's about 7.5, 7 foot long, somewhere in that range as well. We use some pretty common radios. There's a lot of parts commonality in the aircraft, in the industry. So really powerful platform. Going to be familiar to a lot of folks and how it's used. The battery in this thing is big. It's probably more than 50% of the mass of the aircraft in the front of the airplane. So it's a 40 amp hour lithium ion battery. It's about a 17-pound cube you walk around with. And that'll get you pretty consistently 3.5 hours of endurance. So that's the advertised number that we use. Then there's the other side, the Skyron XLE, which let me tell you, doing flight testing on this, you might as well bring some popcorn because it's 7 hours in flight is a long time. But it'll do it. And it does it stable. And the cool thing about all of this, for a lot of you guys that are operators out there, this platform, there is no operator configuration change to go between battery and fuel cell. All you have to do is just swap out that nose cone and the fuel cell and everything. It's all plumbed on the aircraft. It's all quick connects. There's no software changes you need to make, no weight and balance changes. All of that, both configurations are still under 55 pounds. So both configurations up to 7 hours are Part 107 compliant. So pretty powerful. We talked about a couple of the different payloads we support presently. We're very heavily integrated with the HD55, or I'm sorry, the HD series from Trillium Engineering, with that crown flagship being the HD55. And then you'll see in the top right of the screen up here, the platform breaks down into these awesome little sub modules and assemblies. And that's how it transports. It all goes in a box and comes apart in these big chunks like that. And there's really just one tool to do it all. So that's super powerful from an operational footprint, right? Like, say somebody walks around the airplane and they step on a wing, you just slide another one on. That's another key thing. All of these parts are swappable between aircraft or your spares kit. There's no configuration, retrimming, any of that kind of thing from an operator's perspective. So we've really focused on making this thing operationally focused. So how do we keep it in the air as much time as possible while keeping the cost down, right? So that's the end goal. Lots of different payload features that, if you guys have ever used a Trillium ball, it's all there. It all works right inside of it. I don't have to speak too much about that, but super high quality payload. Some of probably the biggest part of making this thing operator and user friendly is our ground control station. This is everything you need right here. These two computers. Actually, it's a box and a computer, and you're flying. What's actually pictured here was an early prototype of our ground control station. It's actually gotten cleaned up even beyond that, and there's a nice little facade around all this. It's fun when you get into your marketing content and you see how quickly things have changed. But yes, that box has been cleaned up. I'm actually noticing some things are swapped around, which is just fun to see as the test lead. But yes, it's been cleaned up. You only need that box and that laptop, and that's your ground control station. And that's what it looks like when you're actively flight planning and setting up your flight zones and your waypoint missions and everything in real time. So you can run up to 2 tough books. So if you've got a really complicated mission set, your crew resource management, as your task saturated, one person's flying the airplane and one person needs to be staring at a payload, tracking something or looking for something specific, you can do that. It's set up. Everything runs on a IP-based network, and you just add the other computer in, open up Trillium software for the payload, and you're watching the payload screen on the second operator or on the second screen, and then the two computers can operate independently and or together. It's actually really neat when you get a good, well-rehearsed crew together, because the GCS operator, the aircraft operator, can still interact with the payload directly through the ground control station. So say the ground control station operator sees something or is unsure where they need to fly the aircraft to position the payload operator. A, the payload footprint is always displayed on the GCS or optionally displayed on the GCS. But B, the aircraft operator can actually queue the payload from the aircraft's primary flight control. So you can click on map on screen and move the payload around. We've got a lot of cool different flight modes that supports or enables as well. So you heard me talk about, I got to mute this again. There we go. You heard me talk about easy to operate. This was a real-time video we recently did. You can set this whole aircraft up from cold and dark and in the box in under 10 minutes and have it ready to go on the launch. So pretty powerful from an operator's side. And it is all autonomous waypoint-based missions. And we've got ingress, egress approach points and everything in there. So you can really tailor, it's a hybrid lift quad rotor. And a lot of times you hear hybrid lift and it's straight up and out, right? Well, sometimes you've got a confined area and you need to go up, over, translate, climb, and then out. We do support that as well. So you can really quickly set that up with, I think it's as few as like 4 button pushes at this point. You can actually get all the way through that waypoint planning process to get it up in the air. So pretty powerful from a platform. We do offer some training on it. We say it takes around 5 days. If you're an experienced operator, that platform, it goes a lot faster than that. I recently taught a couple of operators that came in. I basically walked them through the training deck and then said, here, try it. And then, or here, walk it through with me. And then, okay, you guys try it. And then that was it. That was the last time I touched the aircraft for the entire week. So that was pretty fantastic. Same thing with the GCS. It's designed around human factors principles, right? So like if there's an operational mode you shouldn't be in or shouldn't be able to get into because it's unsafe in a specific phase of flight, it's not even on screen. It's grayed out or disabled. So we've got all of that built into the system as well. So some cool glamour shots here, and then I'll turn it back over to Brent. Yeah, that's a quick run through of Skyron X and AuroraFlight Sciences.
Kendall, that is a tremendous platform, and it's amazing to see that modularity, what that can lead to. And then, it's just really cool to see that 10-minute setup as well. You can get on site, you can get everything prepped up, and you're in the air, so quick. This is a really great asset if you have, you know, different users like say accident investigation. We've been looking a lot at aviation accident investigation with this technology because it's non-invasive, so it can get in kind of close and get a big picture of a scene.
Right.
It can also provide support for emergency response. So
Yeah.
tremendous opportunities here.
And
Um,
it's something else. If any of you guys online are ever in the Virginia area and you reach out to the team, um, it is something else to see this thing fly because you don't hear it flying. So when it's up at 400 foot and it cruises overhead, it's whisper quiet. So it's pretty cool too. So it's low impact in all the ways you can imagine there.
so low observability. That's
Yeah.
tremendous for intelligence, surveillance, reconnaissance use, ISR. I want to ask some questions about field observations and just some of your professional lessons learned. Uh, what are some of the real world challenges that you've encountered in flight testing that maybe don't always show up in your sandboxes or in your simulation or even in early design phases?
Okay, I've got one phase or one phrase that has just stuck with me forever. One practical test is worth 1,000 expert opinions. Let's just leave it there. You can run everything you want in the sim. You can test it all and all the clickology and all the different ways the software interacts, all virtually. But the real proving ground is the real world, right? Like, so I have so many stories out there, and it's hard to think of just one where everyone, and you go for a readiness review or a test review or planning, and everyone says, yeah, it's gonna work, and then you get out there and it just doesn't work at all, or totally find something out that just was unintended behavior. Things may have gotten exciting, or it just never got off the ground at all. But yeah, I mean, the simulator has a lot of value, and the simulated world has a lot of value before you get to the field because it avoids wasting time, right? So flight time is valuable, and every time you exercise and flex that muscle to get to the field, it's expensive. So you want to try to minimize going to the field and doing troubleshooting in the field. So I'm not discounting the value of simulating and testing in the lab environment, but it's critical to actually operate as practice like you perform, right? So if your intended user is going to use it one way, we should be testing it in that same way.
Excellent. So going to the modularity component here, how do you see modular and hybrid designs like you've got with the Skyron X shaping the future direction of SUAS development? We have now a lot more expanded opportunity. BV loss, we are right on the cusp of it with Part 108. We now have, a lot more routine operations that, several years ago required a lot of waiver and oversight. How does this technology and your operational strategy with the modularity, how do you think that's going to change the game?
Well, specifically to Skyron, I think that the modularity of the platform means that it's almost, I say this with a lot of asterisks as a tester, right? So it's almost infinitely variable in its use case. So at its baseline, you can think of this platform as an F-150 pickup truck, right? So it's a pickup truck. Its only goal in life is to get in the air and carry the main objective, which is the payload, to the place it needs to be to observe something, to detect something, to report on something, anything like that, right? So the whole point of the modularity is to make the barrier to entry to get your payload in the air and operating and flying as low as possible, right? So I think that we're positioned, and this platform is really positioned in a cool place to be able to enable that. And then also in the background, I'm not super familiar with the history there here, so this is a reference that I've been digging into a little bit lately, but the car industry used to kind of be the Wild West, right? So there was just hundreds of manufacturers out there, and everyone had their own idea of the right way to do things. I think there's a conglomeration coming where a lot of people are going to start narrowing in on the same direction, right? Like a truck kind of looks like a truck. Like when you think of a pickup truck, they all kind of look the same now, don't they? Minus, the Cybertruck. But they've all kind of headed in the same direction, that same cab look with a truck bed on the back with the sides and a bed that folds down. I think we're kind of headed in that direction. And I think that the people that aren't on board or kind of getting into the mindset of away from the gee whiz wow and into the supporting the mission instead of making the next coolest thing, I think that that's starting to transition a little bit, maybe move away. But yeah, and then also what's supportable about this platform is, and all the modularity, it's a very open architecture, right? So that means it plays nicely with others. So other companies' payloads and other companies' mission control systems, and it really does tick and tie there. And it's becoming more of a collaborative environment. And as you mentioned, Part 108, a lot of these systems are going to start standardizing, right? So you're going to have some kind of detection and avoidance mitigation. And I think there's going to be some pretty standard means of compliance to get along that. Similar to, love it or hate it, remote ID has this ASTM standard, right? We're all trying to get on board, and we're, working with the right agencies and the right reviewers and whatnot to try to make sure that all that's together. I think it's headed the same way with ground control stations detect and avoid data links. I think that's all going to get relatively standardized. And I hope that that doesn't crunch down on innovation, right? So standardizing is great to get us moving down that pathway, but the concern that I have there is that will slow down progress at the same time. So anyway, back over to you.
And that's a rational concern, and that's something we've seen quite a bit over the last really decade. Is we've seen the regulations kind of come out, put a pretty much a blanket stop to operations until, okay, now we've got an understanding, and that led to the COA, Certificate of Authorization or Waiver, and then Section
You mentioned
333.
blanket stop. I was
Yeah,
at Embry-Riddle when that blanket stop came out, pre part 107, and there was a moment of uh-oh. Or what are we doing next? Because that was everything I did every day was, UAV operations, UAS operations. So it was a little bit like, oh boy.
in that time, we were trying to figure out, what does this mean for like groups like the AMA, the community-based organizations.
Oh
Like,
yeah.
are they going to have a path forward? And now we are on the other side of it, and it's it's made it much clearer how we are supporting safety with what we're doing, and I think we're getting there. Looking at remote ID, we see a lot of parallels between ADSB, TCAS, that technology, and I think we're going to eventually get to that more interoperable solution that'll work across the board for everybody. The question often comes up, why aren't we using ADSB for this? And just to kind of expand for the students listening in, um, every aircraft, every conventionally piloted aircraft out there is equipped with ADSB. And if you put the I don't even know what our number is right now with SUAS, over a million.
That's
It,
gotta be.
It's if you put all these platforms out there with this in there, it would super saturate the scopes. So folks that are flying, especially high altitude fast, uh, they wouldn't stand a chance to know what else is out there because they just have everything on their screens. So right now we have the separated remote ID dongle or integrated component into modern platforms. So Kendall, based on you mentioned collaboration, so I'd like to ask, based on your experience working, different companies and collaborative opportunities that you've supported, what approaches have you found most effective in integrating UAS into larger aviation operations? You mentioned
Wow.
crew resource management, so
Yeah,
walk us
so
through
larger aviation operations, it's funny. We're all kind of us pilots. I say us pilots. I aviate in general aviation as a hobby and for personal travel. So I try to, it's all pilotage, it's all aviation. But then the traditionalists, you can have the argument of, oh, you're not a real pilot, you fly drones, right? Like everyone has that conversation at some point in our industry. But we're all kind of birds of a feather, right? So like I've never walked into an operational environment with a bunch of other pilots and actually had a hard time integrating with a bunch of other operators. Like we all kind of understand how to communicate. We understand what's important to achieve the mission and how to communicate when we need something actionable out of another person or we need to interact with another person and get their attention. It's never really been too much of an issue. We actually internally at Aurora, our flight test group, it's interesting because I work with a lot of engineers, right? So they're not always super well versed in the aviation and crew resource management side of things, and they don't actually they tend to have a little bit of a harder time adapting to that type of communication and operational cadence. A lot of times they'll just come out to the field, and especially in like experimental software or something, and they'll just have their software on board and they'll start executing down their test card, not say a word. And us as like a safety pilot or whatever are out there going like, that's cool. What is it doing? And then you take over the aircraft and hand fly it back because oops, I didn't communicate that I was running card F5 and oh, I'm pushing the button. Okay, pushed the button. Okay, I see it doing something. Okay, that's what it should be doing. Like that whole closed loop of communication. But yeah, when you're collaborating between other companies and other entities in an operational environment, I've never really seen it to be too much of an issue. In fact, what you're seeing pictured here is actually a private airport. It's a grass strip is one of our test sites. We interact with general aviation and aviation pretty regularly out there, and it's pretty collaborative. We get on the radio and we talk just like anyone else, and we deconflict. We get out of their way, but it's usually just not an issue.
excellent. What advice would you give students today that want to pursue careers in UAS flight test and development?
Get involved and get active. Find the RC club on site. Go out and fly RC. Believe it or not, the most foundational part of my career and where I'm at in this testing regime is, believe it or not, the hobby side. It's funny because I think Brent and I had a little pre-conversation. The early days were, redundancy and system reporting and health monitoring and all that. And we're kind of in this collaborator or this phase of development where the customer and the end user only cares about how easy it is to use, how long it takes to train, how do I maintain it, and how much does it cost, right? Those are the big questions. And how far can it go? How long can it fly? And what are the limits of that? That's really all they're after. They don't necessarily want, redundant failover, co-processing autopilots and double control systems and all the big cool, marketing buzzwords that we'll throw in because engineering teams love to just make the coolest thing ever. It's simplifying. It's getting a lot more simple. And the foundational knowledge on how to make that stuff work comes from the hobbyist group, right? Like these servos are just professional versions of the hobbyist side servos. The linkages are just professional versions and polished versions of all of that now. Like it's all gotten cleaner and better because everyone's using them now. And the availability is way higher. It used to be just your local shop. Now you can get them from sourced and reputable locations and places, and they'll build them to suit if you've got custom sizes and things like that. But knowing where that stuff is and that it exists and how it's used, foundational, makes all the difference in the world, right? So what makes an airplane fly really well? Go out and build a model airplane. Try some things. Just that foundational, like what makes an airplane fly well, is super valuable in this industry.
Are you guys still using nylon clevises and metal push rods in this thing, or is it like
No
right?
nylon. No
Okay.
nylon. No nylon, but there are some pretty common parts on there, yes. But no nylon.
Nice.
Everything's pretty hardened at this point. It's all metal or better.
Okay, nice,
Yeah.
nice. So, talk to me about how you stay current in the field. In like 3 weeks, we have the Super Bowl of our field coming up with AVSI Exponential. Uh, that's one way, but how do you stay up on regs or the latest advancements that are coming out, or the next level of certification that's being offered? How do you as
Yeah,
a professional stay ahead of it?
that's becoming increasingly difficult actually, just as things ramp up on the operational cadence. Believe it or not, industry publications are huge. So the AUVSI, I think they called them the e-briefs or something along those
Yep.
lines. Those were huge. They do a lot of webinars. Those were big. Believe it or not, the FAA does some pretty cool like industry conferences and telecoms. They have a Zoom probably once a quarter. It's like state of, I can't remember what they call it, state professional US, state of the industry or something like that. Um, just finding all of those little free out there, talks and publications are huge. And then also following things just like online newspapers. LinkedIn is huge. I'm on LinkedIn probably twice a day. I hop on there for maybe 30 minutes at a time. And just that seems to be where everyone in our industry is posting all of the latest updates, right? Like it was kind of funny. We were talking like, when Starlink Mini got lowered in price, I was like, we should be throwing Starlink Minis on these things. Like that would be cool, wouldn't it? And then like later that day, I go on LinkedIn and somebody's already got like a mount and then the right hardware and then like a PoE switch and everything that would just plug right into our system. Like it was all just right there on LinkedIn. I was like, yes, like those are awesome places to find that. Um, Part 108, like probably the biggest question right now is, it's all a little bit of hearsay at this point. Nobody's really sure unless you're at the FAA writing the regs. And that's for competitive advantage reasons. I totally get it, but not really sure what the progress is there other than it's behind. But I think Part 108, when that notice of proposed rulemaking comes out, that's going to be the game changer. And we're going to see some huge movement as everyone tries to get on board in front of that becoming law, right? So that's probably the next biggest publication I'm looking for, is that Part 108 being published.
Well, and folks, just to think about the implications of this, when we can get to routine beyond visual line of sight operations, you're going to see operational time on platforms, I think, dramatically increase.
Oh,
And
huge.
the observations and data that we can then collect off that's going to feed into other channels. I want you to think about advanced air mobility, the eVTOL air taxis. They're doing those individually right now, type certification, in very, very tight controlled environments, in corridors or over specific airfields. They're not going real wide scale with them. However, if you think about everything we're going to gain with Part 108, the data, the insight, the observations, the better understanding of how this technology can interop with the environments that they're in, the very unique environments, whether it's weather, terrain, operational considerations, all that can then feed into what we need to know about air taxis and that technology. We can combine it with what we already have from general aviation, and it's going to give us a much more comprehensive picture to understand how does autonomy play in this space, how does command control and communication play, especially things like latency, uh, and the dependency that that distance is going to create on our communication infrastructure. So kind of put that all together as we're looking at this technology over the next remaining 3 weeks. This is really, I think Kendall hit exactly on it. This is going to be a huge game changer in everything that we're doing.
Oh, it's going to cause the industry to explode. Like you said, that operational time is just going to go through the roof. Because right now, all of it's being reviewed on an individual case by case, con-op by con-op review with the integration office at the FAA, right? So it's a small group of people inside the FAA reviewing every person's waiver submission to go out and fly a power line. So, publishing what they're looking for and what makes us what the government views as a safe operation is what everyone's going to model off of, right? So whether it's going to be some sort of visual detect and avoid, sensor fusion with ADS-B in, with a visual, with an alerting system on the GPS, whatever that accepted means of compliance to do that type of operation is, it's going to change the game.
Well, we just answered inadvertently my last question, which is, what do you see as the biggest growth opportunity? So, with that, I'd like to offer to open this up to the students who are in attendance. So, if you want to, Jacob, you want to get us fired off here?
Hi, Kendall. Thanks for joining us tonight.
Hey, Jacob.
So I had a quick question about payloads and the powertrains. It looks like there's a pretty wide range of weights from heaviest to lightest stuff. And can you go into a little more detail about how you would swap those out without having to do some sort of ballast for the weight and balance adjustments?
Sure. So you buy your payload noses from us, right? Those payload noses come pre-configured such that the mass and CG of the aircraft doesn't change regardless of which payload nose is on board.
So that's already factored in how your CG is going to change, and it knows based on the payload that you plug in how it's going to adjust and can make that correction automatically?
It's even simpler than that, but yes, effectively, there's nothing that the end user has to do as long as they've gotten the payload through AuroraFlight Sciences. Yes.
Okay. Very cool. Thank you.
Yep.
I believe Joe is next.
Hey, Kendall, thanks for the presentation today. My question was actually very similar.
Yeah.
But yeah, so just to confirm that neither aircraft use any type of fuel, is that correct? Both battery, just different types.
So you're asking what are the fuel types? So one is battery. Let me see if I can get PowerPoint to work with me here. And then the other one is hydrogen fuel cell. So it's actually a hybrid. So it runs on hydrogen as its primary fuel source. And then there's an onboard like buffer battery you can think about. So it's a lithium polymer battery. It's a different chemistry battery, a little higher energy density. But you see that 800 watts. While it's in flight, the fuel cell actually generates more power than we consume. So it actually recharges that buffer battery.
Gotcha. So that's, again, back to the ballast question. You're not deciding a weight and balance based on DA or winds or something like that. You're just plug and playing what you're doing, a fuel cell or the 40 amp hour battery, and going as is, as kind of Jacob asked as well, just plug and play.
Correct. It's plug and play. So there's no
Nice.
weight and balance you have to do from an end user perspective, no parameters you have to change. We might actually have a checkbox, I think, that just says fuel cells on board, and all that does is it tells the fuel cell to turn on when you take off. I think that's it. But the autopilot, the mission system doesn't need any more information other than that to operate. The aircraft treats the fuel cell like a battery.
Gotcha. And then if I may ask another follow-up, I actually operate with Trillium and Cutta as well. On the
Okay,
aircraft
so you
we operate.
saw some familiar stuff there.
Yeah. Do you find maybe it's just a software thing, or we're going through the military on my end, so it's a lot longer to get things done. But does Trillium integrate with Cutta way better than I'm envisioning, I guess? Like we can't right click on the map and say, Q payload to X coordinate, things like that nature. Do you find it that it's a lot better integrated on your platform?
Yeah, so right now you basically zoom out on the map where you want to look. Say you're queuing it through Cutta. So zoom out on the map and you go to point, and then you click on the map and it'll slew the camera where your point location was.
And that's through Cutta, not Skylink?
Through Cutta or Skylink.
Okay. Oh, that's great. Yeah. All right. Awesome. Yeah, it's cool to see where we should be on our platform. Appreciate the presentation.
No problem.
So I'm going to quickly cut over to the chat, and then I'll get back to our list of folks with their hands up. Bill asked, "Has this been kinetically tested for anybody in Virginia that might need that?" And I'm gonna kind of put maybe a scope on that. Kendall, you could choose to answer or not, but we can also look at this from the perspective of frangibility and potential of flying it over people rather than crashing it into something.
From the scope of flying it over people and connect testing, it has not, but you can do some quick math on cruise speeds and weight and come up with some numbers there.
And our next question, I believe, is Matt. Heidi.
Hi, Kendall. Appreciate the presentation. My question was, you said that the wingspan of the thing is 16.5 feet. Do you foresee the regulatory changes on this? Because it's also under 55 pounds and meets the Part 107 restrictions. But 16.5 feet is hardly a small UAS. So would you foresee like the FAA coming down with having a wingspan restriction on small UAS as well as the weight restriction?
I don't think it's going to be a size restriction as much as kinetic energy related, if I had to put a qualifier on it. And the cool thing about something like Skyron X is at its fastest pace, it's 50 knots. So like you can almost not get it above that. And you can slow it down. We say 30 knots. I'll just leave it at 30 knots. 30 knots is a comfortable speed for this aircraft as a minimum speed. So you can scale that speed based on what your operational needs are. Now, a platform like Skyron, it's super sensitive to that airspeed, right? So like the faster you go, the more power you're going to consume in flight. But yeah, I mean, it's all traits, just like anything in aviation.
So I'm going to pop something just over into the chat. Just for flight over people, that'll kind of get you into the performance standards with UAS, including things like frangibility, how they break apart, and if that, as they break apart, how dangerous that can be to humans, or if they hit, the shards or people or components hit people, how and why they might be dangerous, and some of the kinetic testing that did.
And I think I missed your question about frangibility, but it does. You saw that modularity in the platform. Let me back up here a little bit. I would wager that if you did subject it to the right kind of testing, it would be rather frangible. So it's made out of pretty consistent materials. It's foam core, et cetera, et cetera, et cetera. So it's pretty standard buildup of the materials and lightweight. If something impacted a wing leading edge with rigid forces, you could do the math on what that moment arm looks like. Things will break if it hits something. So, which is a good thing in that case. I see a question in the chat about scenarios like disaster response. Sure, we've actually done a couple of collaborative efforts with some disaster relief out west for wildfires. So particularly the HD 45 and 55 have great EOIR platform or great EOIR platforms, and they will use those sensors on board Skyron to go and map hotspots at night. So a lot of the traditional aircraft have a hard time getting up and flying in the smoke at night, and this platform works pretty well at finding those hotspots on the ground. And so with a payload or with a software like Trillium's or even in Kutta, you're able to mark those hotspots pretty much real time as you're flying over the area. So, and they show up like the sun at night. I think you saw some of the clip in here. Like this was actually, there's a couple of clips right here. This is a utility vehicle during the day. And it's actually flying along. They're just running along in the shadows of the woods right here, and stuff that's warm really just pops. And that's a low res image, so it's even cleaner than that on our GCS. And like I talked about earlier, our GCS allows both the aircraft operator and a payload operator, if you want to operate that way, to see the same image while flying.
And folks, just to clarify, EOIR is electro-optical infrared. So that's your key payload. No worries. It's some folks, this is their first exposure to ISR. That's that intelligence, surveillance, and reconnaissance payloads that are
Yeah.
are common on a lot of UAS. So
Yeah. And
it's
another
one
big
of the
contingent.
things.
Oh, I'm
One
sorry.
of the things
Go
Kendall
ahead.
talked about was payload being the purpose, and with UAS, in many cases, that's what they're all focused about, carrying that payload. And in an ISR mission, your payload is your instrumentation suite. It's absolutely critical. Sorry, you were saying?
Yeah, another big push. Logistically, it was rough because of where I was at up in the Panhandle when Helene came through. But a big push is actually we're actively in the process of working with a couple different agencies. Is that disaster response, like for storms and et cetera. So mapping out like or total devastation on roads, like landslides, things like that. This is another powerful way to check that real quick, get that bird's eye view before all the infrastructure and supporting comes back up at airports and the maneuvering of all that equipment comes in. Florida is pretty good at it though. So it was interesting for our team to see where those resources need to be staged and things in advance. But yes.
So did you work with FDEM, the Florida Department of Emergency Management, like the folks at FSU?
I did not directly, but I know a couple people that were in touch with them. Yes.
Excellent. Excellent. Yeah, they're pros.
Oh yeah. Yep.
I think Anthony, you've got your hand raised. I think you're our last question of the evening.
Yes, just one moment. I gotta go over the right.
And you can always type it over into the chat if you want to do that, and I'll read it out. Whatever you prefer.
Okay, I'm sorry about that.
Oh,
just had my brother come home and the door was locked. Anyways, going back to the TCAS integration and ADSB, I actually was thinking about that during one of our previous conversations. So yes, if you integrate all of the UAS into the ADSB system, you'll just flood the system and possibly even overload the servers on it and possibly even cause a crash. Now, with that being said, they could be operating on a different system, similar in ADSB fashion, you know, just reporting altitude, direction, and all of that. But the ATC would be the only one that has the joint information from both general aviation aircraft down that low and the UAS. Now, with that being said, what do you believe is the feasibility of that? Because I mean, they already have the ATC kind of separated across the different fields, whether it's high altitude on the airline lanes or low altitude near the airports for landing and takeoffs and such. If you could provide input.
So just to clarify right now, ADSB is only allowed on UAS at the administrator's direct approval. So it's big platforms. So I don't think you're going to see it. I mean,
yeah. So Skyron did have ADSB out, but it's such a unique use case. So like we talked about that fire response, because of the operational environment, they had to have ADSB out because the helicopters had to see it and things like that. But yeah, you're right. It's actually specifically prohibited to have an ADSB out transmitter on your SUAS under Part 107.
Tracking. Okay. I was just looking at different options, different ways around of possibly using that, because I mean, it is very helpful to be able to track all of them, but as you said, there's just way too many, and
so the onus kind of falls on you as the remote operator, the Part 107 operator, to be aware of your surroundings, and you can use ADSB in with a laptop setup, even a tablet. There are tablets that now will display it with a dongle, so that you can see who's in your area, so that you can make sure to deconflict before you can visually or auditorily detect them. That's one option. The other, I believe Kendall talked about, they're on the comms. So I know in the past when we operated out at Co Field in Daytona, that's a very popular flight training area. Lake Ashby traffic would come through, do low level passes, um, and we were constantly just, every 15 minutes, a quick broadcast to Lake Ashby traffic. We have small UAS operating in the area under 400 feet, just to let them know so that they're not going to dive in and we're not paying attention, so that they were aware. So Kendall, how do you guys deconflict?
I mean, that's a really good way. There's also, as a best practice, the FAA is actually in the Leidos NOTAM. Now I can hear the system in my head. Welcome to the Leidos outage and notice to airmen reporting system. Are you calling about? I can hear the whole phone prompt. They actually do really appreciate, and it's probably because nobody knows that you can do this yet. You can actually place a NOTAM over your area of operation for UAS, and then provide the FAA a contact information. So if they've got like emergency operations in that area or whatnot, it'll actually depict, like, I got ForeFlight on my iPad here, and I can actually see areas of operation. Like if you went up to like the DC area around the CIFR right now and looked at like if you've got an access to ForeFlight and you turn on NOTAMs and TFRs, you'll actually see a bunch of little circles, gray circles around. And if you tap on those are actually notice to airmen's for, yeah, exactly, drone notices. And it's all reported through that notice to airmen system. So that's another good way. But the radio just seems to work. And it's so funny because for a long time, people were like, nope, you can't transmit. Nope, you can't transmit.
Nope.
And now it's, you must, like, if you've got a specific waiver, it's, you must have one and you must transmit. And so it's just funny that the time it takes for people to realize, okay, this actually works really well. Everyone in the area hears it. If you know,
it's consistent.
Yeah.
It's consistent with the way aviation operates. It's the known channels that are already proven and reliable.
Yep.
So it's as long as you're not, leaning on the push to talk, or just constantly chattering, I think you're good to go. So you got to use it judiciously and responsibly.
But there is a next layer to this. So he asked about other technologies. There is the unmanned traffic management system work that's also going on that not a lot of people hear about. It's kind of like, I see some talk about next gen and whatnot, and I would be willing to bet that next gen will plug into this technology that's being developed. But there's a fair number of companies like Wing and Whisk and what's the other one? Oh, Prime Air. There's another one that they did a bunch of stuff in Zambia, I think. It's
Zipline.
Yep, Zipline's working their own platform. NASA is sitting in the middle of all of this and kind of being the mediator. I used to work at a company called Aeros that also worked on this. And it's I see it popping up right there, the unmanned traffic management system. So they're trying to figure out how to get all of these different, what they call USPs, unmanned UPS or something like that. It's unmanned system service platform provider or something along those lines. And everyone, so like, say you guys already identified who our GCS is and how we use it and everything. So say we want to integrate into the national airspace system and we want to be collaborative with deconfliction. We would pipe our telemetry, real-time position data on like where the operator is, where the aircraft is, what our planned mission is, current airspeed. So a lot of the things that already happened in the national airspace system, we would be piping that over the internet to some sort of platform provider that's then deconflicting all those UAS. And then there's probably going to be another layer on top of that the FAA is then seeing that's filtered. Like if something rises through a certain threshold that then as a conflict gets filtered into the traditional or next gen platform system. But that's kind of how I see that going. And hopefully that gives you a little bit of insight. I think that was Anthony.
Yes, yes, that definitely provides me a lot of insight on that. And the primary reason I was asking is because of that BV loss. I know that there's going to have to be some way, somehow, somebody's got to be tracking for that deconfliction, as you were saying. And, if the unmanned traffic management systems would most likely be the way that it goes. But I was just thinking of, for instance, as you said, with the Amazon Air operations, those drones are going to be coming out of facilities 10 to 20 miles away from where it's probably going to be delivered. So that's going to be difficult for the operator to be able to identify aircraft visually.
Yeah, and they're trying to deconflict all of this stuff. It's actually a really hard equation in math problem, believe it or not. So once all of these different providers, we'll call them aircraft are transmitting their information, then there's a back end mathematical problem of deconflicting who's going to be where when it has to happen as well. And so then you've got to green light an operation or suggest an alternate or hold at this location. So they're trying to automate all of that as well. And it's a pretty tough problem. And so Part 108 is the big thing, but this is also just as big of a thing that's going on even further behind the scenes than Part 108. And it's kind of cool because industry's driving it. The FAA is not actually, I mean, the US government is putting money into this, as in NASA's being kind of the mediator of it all, but industry is actually developing it. So it's pretty cool.
Definitely. I appreciate
there's been a lot of talk of what might be in Part 108. And I mean, I don't want to speculate too much, but I wouldn't be surprised if we see a specific endorsement or rating requirement. There are going to be some level of detect and avoid expectations in there that are most likely going to be a combination of procedural with technology. I wouldn't be surprised if you have to file like flight plans to get operational approval, kind of like a more advanced Lance type system. So I think it's going to be definitely more complex than Part 107 for sure. But when it hits, we're all going to be spending a lot of time with that NPRM. Hopefully, it won't be like the NPRM and the call for 107, which the phone lines got jammed. I think the first like 500 people got on the call, and then everybody else was out in the cold for like 2 hours.
Yeah.
It was up to all of us to parse it out and share it with the world. So hopefully now technology can accommodate, but it's going to be exciting.
I'm ready for it. I know the industry is too. I mean, all it does is it actually serves the industry and the public better, right? Like that's the whole point of it, is to enable things to happen quicker, lower cost, more responsive, and work in the, I think back then, and people still talk about it, the dull, dirty, and dangerous, right? Like the hard places to get into. That's where this stuff really shines.
Well, excellent. Well, as we approach the top of the hour, I want to say thank you for everybody for joining us tonight, as well as a huge thank you to Kendall for sharing his thoughts and expertise regarding where we're heading with flexible and scalable UAS. This has just been a tremendously informative session, and it really helps us to better understand the challenges, the capabilities, and even the opportunities that are associated with this technology. Students, for full credit, remember you need to add your brief discussion entry, the single post, by Sunday. You don't need peer replies to your colleagues who are talking option A, but I would strongly encourage it. It helps them to further engage, and there's no harm on your part. You might learn about some of the investment opportunities of the technology challenges that are occurring from the business perspective. Make sure in your own post that you describe any new info you weren't previously familiar with and how your overall understanding of the topic has improved. And with that, I hope to have the session uploaded to our instructor corner in the next day or two. So I'm going to stop our recording.